I said the following here. I'm going to get out of this for just a second and come back to here. I said we were going to do the warm-up, which we just did. Hopefully you actually attempted the warm-up, because next week that will be some of the types of questions that will be on the test. In fact, that brings me to number 2 here, which is the reminders. The first reminder that I would like to mention is when you're attending class virtually, I really need you, even if you're in person, I need you guys to answer the poll questions and the exit slips. Those are not graded, but it really, I feel like if you're going to be engaged in this class, it's the very least that you can do, that you can just go ahead and submit those things. They're typically multiple choice. I might ask you a question. I'm not really concerned that you get it right or wrong. I mean, I'd like you to get it right, but it just kind of, you know, when there's 20 some students and only 10 people answer it, it kind of makes me feel like it's a waste of my time. And I'm trying to help you guys stay engaged by doing things like that to help you kind of be accountable for what we're doing in class. Number 2, I just want to let you guys know I think you're doing a good job of getting your homework done. Please remember that that homework is online, but it is not the minimum of, or it's the minimum of what you should do if you really want to be good at some of these calculus things. In addition to the assigned homework, there is extra practice problems that I put on every module, and those are mainly odd numbered problems, so you could easily check your answers on CalcChat and CalcView to see what the correct answers are. So those are good ideas if you're trying to, you know, figure out how can I do better on, let's say, particularly, let's say the section we just talked about, section 4.6, you're nervous about that for the test next week. Maybe do some of those extra problems. They're already there waiting for you. I'd like you to really think about that if that's something that you feel like, man, I don't really understand, let's say, log integration. And that brings us to my final reminder, is that next week we do have our first test for this semester. Remember that tests are worth quite a bit in this class, so doing on that test is important. I do curve tests, as you know, so I don't want you so stressed out that you're in tears, but I do hope that you're taking the test seriously. So the test next week, just to make sure that we're clear, the test next week will cover sections 4.1 through sections 4.6. In other words, it is not covering anything that we're doing this week. Does anybody have any questions about what's going to happen this week or next? Okay, so I'm going to go ahead and go back. All right, so our objectives today are to integrate functions whose antiderivatives involves inverse trig functions, and to use the method of completing the square to integrate a function. So we only have 2 objectives. And I'm just going to forewarn you, today's integrals are kind of scary looking, but they're actually not too difficult. So before we get to that, let's take a minute to go back and think about all the way back in chapter number 2. In chapter number 2, in fact, I'll note it was section 2.6, section 2.6, which we covered on October 5. And by the way, guys, I'm writing on my tablet here, so I know it probably doesn't look, you already know my handwriting isn't the greatest. But anyways, back in October, we talked about what is the derivative of arcsine. And remember, on your calculator, arcsine is going to look something like this. It'll say sine to the negative 1x. That means the inverse of sine. So the derivative of arcsine turned out to be 1 over the square root of 1 minus x squared. And then we had some other ones. But I just want to bring this to your attention because way back then we were talking about differentiation. And now we're going into integration. Before we move on to the next slide, I have a quick poll question for you. If you would please answer that. I'll give you a minute. Please answer the poll question. Like I said, the poll questions really aren't difficult if you're paying attention. Okay, about 10 more seconds. Please answer the poll question. I only have about, oh, I'm getting there. We're almost done. If I get one more answer here. All right, it looks like the majority of you have the correct answer, but 6 of you do not. So would you please make sure you're paying attention? It'd be nice if you were actually engaged in writing some things down and not just staring at the monitor, mindlessly following along. Okay, so here is the most important slide for what we're going to do today. In this slide here, I outline the 3, and I'm only going to focus on 3, the 3 integrals involving inverse trig functions. So we are basically doing the reverse of what we did back in chapter 2. In fact, the one that I just mentioned on the previous slide was the derivative of arc sine. Now we're going to look at the integral of du over the square root of a squared minus u squared. Well, that's going to be equal to arc sine of u over a plus c. And then we have one for arc secant. And probably the one that's most likely to be seen on the AP exam, which would be this guy right here, is arc tangent. Now, guys, I have no idea of exactly what they're going to put on that exam. They may put something different than this. But if I had to bet, the one that I've seen the most in the past is that arc tan one. I would be familiar with that. Now, these formulas pretty much look insignificant, or at least maybe even confusing if you're trying to figure out what to do with them. So let's look at a few examples. I'm going to start with an easy one here. Look at example A. So by the way, both of these, notice I said integrate the following using arctan. So there's no surprise. The one that I think is probably most likely to be on the AP exam, I'm going to kind of emphasize that right from the get-go. So if you want to integrate 1 over 3 plus x squared, the first thing that you want to try to do is figure out what u is and figure out what a is. Because if we look at that previous slide, you'll notice that there's a u and there's an a. So when we look at this problem, the u is the variable term, and in this case, it's x. U is going to be x. A is not 3. It's going to be the square root of 3. Now let me go back to that previous slide again. Notice it says the integral of du over a squared plus u squared. So a is the square root of 3 because the square root of 3 squared is 3. And u is x because x squared is x squared. Now we have all that we need to complete the answer here. So using this slide on the previous, or this formula on the previous slide, we'll get our final answer here. The answer is 1 over the square root of 3 arctan, and then you just put x over the square root of 3 and then plus c. Now, honestly, I hope you see that example and you think, well, that wasn't too bad. And I don't think it is. I mean, I started off with an easy one. Now, notice I put square root of 3 in there instead of, like, if that had been a 4 instead of a 3, it'd just be 1 over 2. Arctan x over 2. So these are not difficult when they're written in this form. Look at B, though. B is a little bit more difficult. So here's the question I have for you. What do you think U is going to be on this one, and what do you think A is going to be on this one? Just take a second and jot it down. I'll hesitate here. Okay, so my hope is that you figured out that U should be e to the 2t. I also hope that you recognize that A is 2. I actually mentioned that on that first example. If that 3 had been 4, it would just be 2. Can anyone unmute yourself and ask or answer the following question? What do I need to be careful about when I actually do the integral on this problem as opposed to the first problem? And it's based on the U. Abby, can you still hear me? Okay. Guys, look at the first problem. You see how u was equal to x? What's the derivative of x? It's 1, correct? So it's 1 dx. So up here, I kind of skipped that step, but technically I could have written that du was dx, right? So that wouldn't have been any issue here. What's going to be the issue with part B, though? Well, when you do du, you're going to get 2e to the 2t dt. Do you see an extra 2 here in the integral? There is no extra 2 there. There is no 2 sitting right here in front of that, is there? So we can't forget what we've done in the past here. I'm going to erase that 2 because it wasn't there. So what we're going to have to do here is we're going to have to write this as 1/2 du is equal to e to the 2t dt. Now I can get to my final answer. My final answer is going to be 1/2 times 1/2 times arctan, whatever u was, well, u was e to the 2t, divided by a, which is 2, plus c. I hope you understand where that extra 1/2 came from. It didn't just fall out of the sky. It came from this step right here. In other words, the final answer is 1/4 arctan e to the 2t over 2 plus c. That's your final answer. Oh, actually, you know what? One quick thing here before I move on to the next example. And by the way, this is the answer for the second one. And then I've got the answer. Sorry again about the handwriting. You'd think I'd be able to write better with my finger than I would on a pen on a board, but it actually is obviously not the case. How could you check your answer for number 1A? How would you check this? Type your answer in the chat or unmute yourself. It's going to be a long day, guys, if I'm the only one doing the talking.
Do you just need to find the derivative of it?
You got it, Rachel. Thank you so much for speaking up. I felt like I was all alone. Yes, you would do the derivative. And I would challenge you guys, particularly those of you that are really serious about trying to pass this AP exam, how do you check that? You do the derivative. I'm not going to take time to do this, but when you do the derivative, if you do not get 1/3 plus x squared, that means you probably need to go back and look at section 2.6 again and review how to find those derivatives in the first place. And I'll just let you know, you have to use the chain rule on these. So be careful. It isn't quite as easy as you think. So anyways, you can check these by doing differentiation. All right, so my first examples involved arctan because I think that's what would be most likely to be seen on the AP exam. I don't think you'll have multiple questions, maybe one, but maybe two. So let's look at these two. Now here I obviously have said at the top that these are arcsine or arcsecant. Which one do you think A is? Is it arcsine or is it arcsecant?
Arcsine.
You got it. Very good. Thank you for saying something. It's going to be arcsine. If you look back at our rules here, if you look at arcsine on the left, it kind of looks like the integral of du over the square root of a squared minus u squared. So this is definitely going to be arcsine. That's kind of the first thing that you need to do when you're doing these problems is kind of recognize what you've got there. So now what we need to do again is we need to identify what we think u is and what we think a is. So u is going to be, well, we've got to think about something squared here. Remember, the u is always the variable term. So it's going to be 5x. Oops. It's going to be 5x. A here is simply 1, so that's nice. So we know what u is. We know what a is. So if we go back to our formulas, we can see that this is just arcsine of u over a plus c. So my final answer here is going to be 1/5 arc sine 5x over 1 plus c. Do you guys agree with that answer? Okay, I think I heard a hand go up. I'm sorry, whoever raised your hand.
Yeah, is this gonna be on the test next week, or are we doing this afterwards, like on a different exam?
Yeah, so I'll go back to what I said on the warm-up. I'm going to keep what I've got here so far. The test next week covers these sections, 4.1 through 4.6. So this is not on the test next week.
Okay, thank you.
You're welcome. Okay, so let's go back to this from current slide. So if this answer for A is arc sine, can you guess what B is going to be? That's going to be arc secant, right? So I'm going to ask you, I just like you to try this one kind of on your own. Arc secant, I'd like you to give this one a whirl. You're going to use the formula down here below. Oops. This guy right here. See if you can do this one on your own. I'm going to give you a couple of minutes to try this one on your own. And then I've only, I think, got one more example to do. Yeah. Actually, I got two. I'm going to do one that's a definite interval. I'm going to do two more examples. And then we'll get to the next piece of what we're going to try today. About 30 more seconds. I hope that someone would be willing to at least unmute yourselves, at least even a couple of you, and just tell me what you think. What do you think U is on this particular problem?
3x.
Okay, thank you. I agree. How about A?
5.
Correct. Excellent, guys. If you've got that recognized, and you know this is going to be arc secant, then you are going in the right direction. So this is just pattern recognition. So your final answer here is going to be 2/5, and then arc secant, absolute value of 3x over 5 plus c.
So does the negative in the denominator not matter?
No. Now, guys, I'm just going to let you know that there may be something incorrect on this slide, and I would like you to ponder it for a moment. If you can't figure out what it is, or if there is something, that's fine. We'll just move on. But I'm going to kind of hesitate here and see if anybody would like to say anything. Or do you think everything's okay?
Is it the 1/5?
This up here?
Yeah.
Okay. I'm not sure who's talking, but can you tell me why you think that might be an issue?
Because it's arcsine. I don't
Yeah,
know.
so when you look back here at arcsine here, when you look at arcsine, was there anything in front of that? Is that what you're saying?
Yeah.
That's interesting. Does anyone else want to talk about that 1/5? Do you think that 1/5 should be there or not?
I think it should be.
Yeah, why do you think, Rachel?
Because when you do like the du of 5x, you're gonna have to divide it and put it in front of the integral.
Yeah, Rachel, I think you're right. I think you're right. Okay, guys, I'm not necessarily saying that there is absolutely something wrong here. I just worry. Sometimes I feel like I write stuff down and people are just like mindlessly following it. And I'm not trying to be rude, but I just want to make sure people are engaged and thinking about answers and making sure that they make sense. And by the way, I should also note that I am human and sometimes I screw up myself. So, okay, I'm going to move on. All right, the last big idea I want to talk about here is something called completing the square. I hope you're familiar with this. I think we've talked about it once before in this class, but it basically comes down to if you have a trinomial. If you remember what a trinomial is back from Algebra 1 and Algebra 2, you can take any trinomial and convert it into what we call a perfect square trinomial. Let me give you an example of a perfect square trinomial. X squared plus 6x plus 9. Did you guys know that that's a perfect square trinomial? The reason that that's a perfect square trinomial, in fact, if you ever have me for Algebra 1 or Algebra 2, I'll call it a PST, perfect square trinomial, is because it can be factored like so. It can be factored as x plus 3 quantity squared. Because 3 squared is 9, and 2 times 3 is 6. So here is kind of the general formula that we try to use with these perfect square trinomials. So what I want to do on this next example here is I want to show you something a little bit more sophisticated. In fact, let me just start this one up. I'm doing this one wrong on purpose. Let me show you the wrong answer, and I want you to ask yourself, do you think you might be the kind of person that would maybe write this as an answer on a test or a quiz? So you get this integral and you think, oh, that's going to be the natural log absolute value of x squared plus 2x plus 3 plus c. Anybody think that? Don't raise your hand. That is wrong. Do not do this, even though you might be tempted to. Can anyone tell me why you cannot do the natural log thing the way it's written there? Okay, the main reason that you cannot do the natural log thing there is because this right here is squared. That's your indication that you're not going to do natural log integration on that one. So anyways, what we're going to do is we're going to do completing the square, and I'm going to do that now. I'm going to write the denominator like so. So what I've done here is I've just taken the 3 and I have scooted it over a little bit. We're only looking at the denominator. I'm not doing any integration here. So my question for you is, now we're going to focus right here. You see that 2? That's the b. If we go back to this previous slide, that's the b. What is half of b? Well, the answer is 1. 1 is half of b. Now, if you're not sure why I'm saying what's half of b, in fact, let me write this here. B is equal to 2. Let me go back to this previous slide. The term in front of x, the coefficient in front of the x, is the b term. We need to know what half of that is. Half of that is 1, and then what we're going to do is we're going to square that. So I'll write 1/2 of b, or b over 2, is 1. So squaring that gives us 1, so that's not very interesting. Now, guys, can I just add 1 to this polynomial and everything's still equal? The answer is no. So what I need to do to balance that out is I also have to minus 1. because you see the +1 and the -1, that adds up to 0, so that does not affect it. That gives me the following. In fact, let me do this in a different color. I could rewrite this denominator as x squared plus 2x plus 1 plus 2. Which, duh, I mean, if you look at that, 1 plus 2 is 3. That makes sense. But what I want you to notice is, what is that x squared plus 2x plus 1? That is a perfect square trinomial. Guys, I got a real quick poll for you. If you would answer that question for me real quick. Okay, I'm still waiting on a few people to take the poll. All right, I'm going to go ahead and end the poll now. So most of you got the correct answer, but I have about 5 of you that did not have the correct answer. So a little bit better than the last one. That's okay. All right, so back to this example. So what I was doing is I was manipulating this denominator like so, which is going to give us x plus 1 squared plus 2. In other words, now I'm going to get back to the integration part. This integral can now be rewritten as 1 over the square root of 2 squared plus x plus 1 squared dx. Now look closely. I didn't write that 2 as a 2. I wrote it as the square root of 2 squared. By the way, what is the square root of 2 squared? Well, it's 2. You'll also notice that I switched the order of these things around. Now, why did I do that? Well, let's go back to our most important slide, which is our rules right here. In fact, let's go back to the rule that I said was the most important of all of them, which was this rule right here. Notice it says the integral of du over a squared plus u squared. So what I have now in this particular problem is I now have this written exactly like I want it. I know that my a, excuse me, is the square root of 2, and my u is going to be x plus 1. And so now I can go ahead and integrate this thing using my rule, and its final answer is going to be 1 over the square root of 2 arctan x plus 1 divided by the square root of 2 plus c. Now, guys, this stuff that I did and read, I just copied that from the formula verbatim. I know what a is. I know what u is. And by the way, what would du be here? Du would just be dx, so I didn't have to do any extra divisions or anything. And that's how it works. Now, going back to the original problem, my guess is, you know, if we didn't cover this section and you saw something like that on the AP exam, you would not get that right. Would you guys agree with me on that? I'll be honest, this is one of those ones where I don't think I would have ever thought of this on my own. Thankfully, some way smarter people than I did thought of it. Comments or questions on this example? I've got one more example, and then we're going to do a little bit of practice, and then I'll give you your exit slip. Remember, I'm trying to stick to that 60-30 thing. We started at 8:45.
So, I have a question.
Sure.
Why, since, wait, never mind. I get it now. I was going to ask, why there wasn't something in front of the integral, but I was realizing you would have to take the derivative of u, which, yeah, that makes sense. Never mind.
Hey, no problem. Thank you for asking. Thank you for trying to think through that. Guys, sometimes this stuff, you know, it comes at you pretty fast, and you're already trying to accept that it's true. And then when you start asking those questions like Aiden did, and let me know, okay? So anyways, we're going to go ahead and move on to the very last example. Here is example number 4. I want to do one example of a definite integral. And I'm going to tell you right now, this example is not hard. This is an easy example. It looks pretty scary. Do me a favor, though. Do not use your calculator yet. We'll get to the calculator in a minute. So look at the integrand. Remember, the integrand is what's on the inside there. Look at the integrand. Sorry. Okay. The integrand here, which one's this going to be? Is this going to be arctan, or is this going to be arcsine, or is this going to be arcsecant?
Arcsine.
Definitely arcsine. So when we look back at that most important slide, we can see that this one looks kind of like this. It looks like du over the square root of a squared minus u squared. So this is definitely going to be arcsine. That's the first thing that you want to recognize. And so now we just need to figure out what u is. And I hope you can easily see that u here is just x. And what would a be in this problem? Well, it's just going to be this guy's square root. So it's just going to be 2. So this is going to work out very nicely. So I'm telling you, I'm just going to jump to it. The answer for this is simply going to be the arcsine of x over 2. And then we just need to evaluate that from 0 to the square root of 2. So this is actually probably the easiest example that I've done in terms of finding the antiderivative, even though it doesn't look like it should be that way. So now we need to do the fundamental theorem of calculus, which is what I'm doing. We are going to do the arcsine of the square root of 2 over 2 minus the arcsine of a 0. Now, of course, the arcsine of 0 is 0. To get the final answer, though, you have to know the arcsine of radical 2 over 2. Does anybody know what? Guys, are you still there?
Mr. Allen, you froze for a few.
Yeah, my internet just went down. Are you guys, can you hear me now?
Yeah.
Okay, cool. Okay, I started freaking out there. Final answer on that last one is just pi over 4. If you think about it, the sine of pi over 4, well, what is that going to give you? That's the square root of 2 over 2. So the arcsine of radical 2 over 2, that gives you the pi over 4. Okay, does that make sense? Now, if you've got your calculator handy, would you do me a favor? Would you just quickly plug this into your calculator and verify that you get the same answer of pi over 4? Now, honestly, you're going to have to, figure out what pi over 4 is with your calculator too. Maybe you should do that first, but verify that you know how to use your calculator to get that answer of pi over 4. So you're going to go to Math 9, You're going to go from 0 to the square root of 2. And then you got to do 1 divided by the square root of 4 minus x squared, and then dx. And then you should verify that that is the same thing as pi over 4. And it is. Okay, so that brings us to 9:30. So now we're going to practice. And, I'm going to stop sharing my notes here. And I'm going to try to share my screen here. Okay, we're going to go to play. Okay, guys, if you would please open up your Kahoot app. The pin for this game is 670-9980. Okay, I'm going to wait just a few more minutes, or not a few more minutes, a few more seconds here. I've got 18 of you in. That's great. I'd like to get up to at least 20, 21. I think I have, how many people do we got here? So we should have about 22, actually. Sorry. Oh, no. Here we go. All right, let's just go ahead and start, okay? So, guys, this is based on what we just did today.